This is Anthony Priscilla with my college algebra class today, and we're discussing matrices and linear systems of equations. Now, linear systems of equations, you've already solved in a previous algebra class. A system of equations is just a collection of equations, and linear means there's no exponents. So you would have seen elimination and substitution already as in a previous algebra class for solving systems of equation, linear systems. And today we're going to see a couple of other methods involving matrices. And first of all, what is a matrix? Matrices is a plural for the word matrix. A matrix is a rectangular array of numbers. A rectangular array of numbers, or a rectangular arrangement of numbers, if you want to use that. With the matrix, we have rows and columns. Row, when I use that, I'm referring to horizontal, and columns are vertical. Okay, so rows are horizontal, columns are vertical. When we talk about the size of a matrix, size, it's the number of rows by number of columns. And just like when you talk about the dimensions of a room, we're going to use a big X for by if you're talking about a 10 by 12 room or 12 by 12 bedroom, 12 feet by 12 feet. So we'll use an X for by, but that doesn't mean times. We're not multiplying the number of rows and the number of columns. When you have a system of equations, we can talk about the augmented matrix. And the augmented matrix for a system of equations is the coefficient matrix. Now, coefficient, those are the numbers that are being multiplied by the variables, okay? Or the variables are being multiplied by. The augmented matrix is the coefficient matrix together with the column of constants. Let's see how what the homework looks like here. First problem, write the augmented matrix for the following system of equations. Well, you're going to write the coefficients. There's going to be, I like to put column headers, an X column and a Y column. This vertical bar acts as the equal sign, and this last column are the constants. Now remember, the constants, that refers to numbers that don't have a variable attached. So like the X column would be -6, and there wasn't a number there, but you notice I put a 1. Now the Y column, what would that be? Well, we have a +5 and a -5 equals 1 and 9. So what I've just written there is called augmented matrix. And then it asks, okay, what's the size of the matrix? Size, you go rows by columns. And remember, what did I say? Rows are horizontal, columns are vertical. So let's see, there are 2 rows, 3 columns. So this would be a 2 by 3. There are 2 rows and 3 columns. Pretty easy to write these augmented matrices from the system of equations, but you need to make sure that you have all the like terms lined up. Notice how the x's were lined up, the y's equal constant. On the problem beneath that, it says same thing, right? The matrix, give it size. Hey, do I need to move down a little? Do I need to zoom it in a little so you can see it better? Yeah, okay, so zooming in a little. There's something wrong here. We have the x, y, and z column lined up, but the next thing should be the equals. X, y, z equals the constant. So what am I trying to say with these green arrows? Yes, did y'all hear that? I'm trying to say we need to move these numbers over. This should be in the form equals -9, equals +2, and equals -2. So let's see. For the x column, there'd be a 6, a 7. There's not an x at all, so what are we going to put there? A 0? Sometimes students will want to put a 1 there, but remember, you put a 1 if there's, like here there was an x. There just wasn't a number in front, so we assume that that's 1x. Here on number 2, there wasn't an x at all. Right there. So let's see, what about the second column? It would be -3, -3, 7, 7, 3, -7. And then over here, instead of a +9, you've got to have that constant after the equal sign. So equals -9, +2, and -2. And what's the size of this matrix that we have right here? Well, the size, let's see there. Remember, you go rows by columns. The rows are horizontal. There are 3 rows, 1, 2, 3, 4 columns. There are 3 rows, 4 columns. Okay. So if you have a system of equations to write the augmented matrix, you've got to have those like terms lined up if you're going to do it easily. Now, could y'all go in reverse? You know how it is in algebra. You always learn it one way, then you go in reverse. Number 3 says, okay, write the system of equations. It gives you the matrix. Hey, let's not, I'm going to hide those answers for a moment. Just go through. Looks like there are 3 variables, x, y, and z. And then I'll just go through and write. At that first row, it would be 5x plus 2y plus a 1z. So just write a z equals 3. What about the second row? There's no x, so don't write x. We'll start right here with the y. 2y plus 4z equals 23. You'll notice how I'm lining up the like terms. It's always a good practice to do. And then this third one, a -1x. I'm just going to write -x. We don't usually write coefficients of 1. Plus 3y plus 4z equals 17. And this is what I refer to as the combination algebra problem and I-test. You got to look really closely. They all start looking alike. Okay, I'm looking at this first 5 and -x. So it's either B or D. Let me see. 2y plus z. Oh, I'm thinking it's D. 5x plus 2y plus z equals 3. 2y plus 4z is 23. If you have something like this on a test, you be sure you look real close, okay? Now, let's do another one like that. Write the system of equations for this augmented matrix. And, oh wow, look at this. How many variables are we going to have at the end? Yeah, 3 variables. So, let's label them X, Y, and Z. So this first equation would be 1x, and then there's no y or z, so x equals 7. This one I'm not going to line up the like variable, the like terms. On the second equation, there's no x or z, just y equals 3. And what's the third one? Did y'all hear that? Z equals 10. And they sort of give you some hints here. Equals 7, so it's just x, y, z, and it tells you to use the letters x, y, and z, okay, to represent the variables. So, look at this. If we have the matrix written like this with the ones down the diagonals and zeros everywhere else, then we actually have the solutions to the equations, to the linear system. X equals 7, y equals 3, z equals 10. So the natural question is, could we take, say, this matrix right here, if we wanted to actually get solutions for this, x equals what number, y equals what number, and z equals what number, could you do that and rewrite it so that it looks like this, with ones down the diagonals and down the diagonal and zeros everywhere else? And the answer is yes. There are things called elementary row operations, which in Math 1324 we discuss a lot of, and we use some technology to solve systems of equations like this and see some really nice applications. We're not going to see much of that here, okay? In class, I'll show you how to punch this into a graphing calculator, maybe a TI-83 or 84, and to get the solutions. But in Math 1324, we go into a lot more detail on how to solve this. But this is all we're doing right now with augmented matrices and something called Gauss-Jordan elimination. That's the process where you go through and get ones down the diagonals and zeros everywhere else. So it's a nice little way of taking a fairly involved system and solving it. And I'll show y'all in class how to punch that into your calculator. Now, the next thing we're going to be looking at is something called determinants. Determinants. So let me get a sheet of paper. We're going to be looking at determinants of square matrices. What do you think a square matrix is? Up here, this is referred to as a square matrix because there's just 2 rows and 2 columns. Like right here, here's another square matrix. It's a 3 by 3. An n by n matrix is a square matrix. We're going to look at how to find determinants for 2 by 2 and 3 by 3 matrices. Now, what the heck is a determinant? Well, let's see. The determinant of a 2 by 2 matrix is given by, well, a 2 by 2 matrix has 4 numbers. Notice this is not an augmented matrix. It's just 4 numbers, 2 rows, 2 columns. And it's AD minus B times C. So they're doing a little cross multiplying. This is called crisscross. A times D minus B times C. It's going to be important when you're doing these that you always don't do B. Sometimes students want to go like this first. They'll do BC minus AD. No. When you start this, you must start with the first number in the matrix. Someone asks you, what's the first number up there? Wouldn't you say this one right here? Like on problem number 5. Find this determinant. I don't really intend for you to memorize AD minus BC. It's the operation that's important. You multiply this diagonal. Don't forget, you've got to start with the first number. So negative 15, that's negative 5 times 3. Then the minus from the formula. And now the green diagonal. Negative 2 times 10 is negative 20. Now watch out for these minus signs. Negative 15 minus a negative 20 would be negative 15 plus 20. And that's going to be what, a 5? A lot of nice little applications of these determinants. So that's how you calculate or find the determinant for a 2 by 2 matrix. Next thing we're going to do, number 6, you see what's common. Find the determinant of a 3 by 3 matrix. Well, this one's going to be a little bit more involved, finding the determinant of a 3 by 3. But you can see a 3 by 3 matrix. Pardon me. A 3 by 3 matrix has 9 numbers. So I think I'll do it like this. Don't let me. Okay. The determinant of a 3 by 3 matrix. Well, a 3 by 3 matrix, I've already said it has 9 numbers. So I'm just going to write it with the first 9 letters in the alphabet. This E is not the irrational number 2.718281828. F is not function. I is not imaginary number. Okay? I'm just writing the first 9 letters in the alphabet. And let's see. Here it is. It's AEI plus BFG plus CDH minus CEG plus AFH plus BDI. And before you panic, y'all see the pattern? There's actually a pattern here, and not intended that you memorize these letters like that. Y'all sort of see the pattern? Maybe the best thing to do to see it is to recopy the first 2 columns. Hopefully you have a feeling that it's going to have something to do with diagonals. You recopy those first 2 columns. The AEI, most people see right off, okay. With it written like this, BFG, CDH, then a minus. Y'all see the other 3 diagonals? CEG, AFH, BDI. So I'm certainly not saying memorize those letters. What you need to do is memorize, this is called crisscross. The 3 diagonals that are going down, you multiply each diagonal, add it up, then the 3 diagonals that are going up when you look from left to right. Make sure that the first diagonal you do has that first number. Make sure you're doing the pink diagonals, not the green ones first. And it's a very common mistake. I'll see students doing the green diagonals first. So on. Number 6. We'll recopy the first two columns. 7, 3, 10, and then 10, 0, 8. I'm about to do the 3 pink ones. Oh, might get some big numbers here. 7 times 0 times negative 1. Well, that's not one of the big numbers. 10 times 10 times 10. Is that 1,000? And then 10 times 3 times 8. Well, 3 times 8 is 24 times 10 is 240. So that's the 3 diagonals, the pink diagonals. Then this minus sign is that minus sign. Now I'll do the other 3 diagonals. 10 times 0 times 10. Anything times 0 is 0. 7 times 10 times 8. Well, 8 times 7 is 56 times 10. That'll be 560. 10 times 3 times a negative 1. That would be a negative 30. And let's see, adding up the pink numbers. Where's my pink pen? 0 plus 1,000 plus 240, that would be 1240. Minus, what do we have in the green? Oops. It's minus right here. 560 minus 30, is that going to be 530? So we have 1240 minus 530. What are we getting for that? Did y'all hear 710? Be a little messy, can't it? There's also a way you can punch this into a graphing calculator, but I'm just going to do it this straightforward way like this, or just the pure manipulative way. Oh, and here's another one, number 7. Same thing. Recopy the first 2 columns. Negative 3, 8, 3, 2, 3, negative 3. And then do the little crisscross. Oh, this is nice. A lot of zeros. I like that. Negative 3 times 3 times 0 is 0. 2 times 0 times 3 is 0. Negative 3 times 3 times another negative 3. So that would be 9 times 8. That's 72 minus okay, let's see. Negative 3 times 3 times 3 is a negative 27. Oh, and then we have a 0. Negative 3 times 0 times negative 3 is 0. 2 times 8 times 0 is another 0. So what do we have here? Watch out for these signs. 72 minus a negative 27. That minus a negative is going to be plus. I'll just write it like that. And what are we getting? A 99? Any questions there? I'm sort of flying through this. Why don't we take a break right now, and then we'll come back and discuss something called Cramer's rule. With Cramer's rule, we'll be able to use these determinants in order to solve a system of equations. Okay? Cramer's rule, a nice way of using determinants to solve systems of equations. Okay? So we'll take a short break and then come back and finish this up.